Hi Algebra 1, this is our third video. This is the video for section 7.3. These are special products, so we're going to be multiplying again, but there's some interesting things that will happen with our answers. For example, the first thing that I see here is x plus 3 quantity squared. So really what that means is that we'll be multiplying x plus 3 times itself, x plus 3. Now, I will tell you there is a shortcut for how to do this. Some students take to the shortcut pretty well and they use it. Others just choose to do it the long way every single time. So I'm going to show you both. And so when I see x plus 3 squared, I could write it out twice just like I did now. And I could use our distributing method. So I would get x squared plus 3x plus another 3x plus 9. I want you to notice 3 times 3 is 9, and because of this you'll always end up with the same number times itself. So maybe something like 5 times 5, which would be 25, 4 times 4, which would be 16, and so this will always be a perfect square. Also in front you'll always get x times x, so you'll always have an x squared. And then in the middle you'll always have the same two coefficients, because on the outside we multiplied by 3x, on the inside we multiplied by 3x. So this will always be double. When we combine like terms, we'll get x squared plus 6x plus 9. And so because of those little patterns, our shortcut goes like this. If you have a binomial squared, all you have to do is take that first term, whether it's a or x or whatever it is, and we'll do that squared. So in our answer we had x squared. This would be a squared. The very last term for our example was 3. 3 squared is 9. So we're going to take b squared. And then in the middle, the way we got 3x, we multiply the outsides. Basically we would just multiply a and b together. And then, like I said, in the end, you would double it. So we would have 2 times a times b. And so you can use this little formula, this little shortcut, if you'd like to, or you can write it out twice. I'll show you that again. So I can write x minus 4 times x minus 4. And if I distribute, I'll get x squared minus 4x in the middle, minus 4x. And negative 4 times negative 4 becomes positive 16. Notice 4 times 4 is 16. 4x and 4x together, that will make negative 8x. And that's our final answer. So for the shortcut, I would have a squared. I would multiply those together and get negative ab, but then I double it. And then the last term is negative b. And when you square that, you get positive b squared, because negative b times negative b becomes positive b squared. And so, if you look at our examples, I'll use the shortcut first this time. So 2x squared, multiply these together, and I'll get, let's see, that's 6x, but then I need to double it, so that's 12x, and 3 times 3 is 9. Now that 2x squared, that 2 gets squared as well. So really it's 4x squared plus 12x plus 9. And let me do it the other way real quick. 2x plus 3 times 2x plus 3. 2 times 2, that would be 4. X times x is x squared. Multiply on the outside, I get 6x. Multiply the inside, I get 6x. 3 times 3 is 9. Put the terms together, and I get 12x plus 9. And that's our final answer. And then over here with example 2, x squared. Multiply these together. Now that would be 2xy, but I need to double it, so negative 4xy. Now this is kind of tricky. We're going to take negative 2y and we're going to square it. So watch what happens with that. Negative 2 times itself is positive 4. and y squared is y squared. So we have our final answer. And I'll do it the other way. X minus 2y, x minus 2y, x times x is x squared, x times negative 2y is negative 2xy. When you have two variables, people usually write them alphabetically, so x goes first and then y. Same thing in the middle, negative 2xy. And then lastly, negative 2 and negative 2 make positive 4. Y times y is y squared. And we can just put those two middle terms together. X squared negative 4xy plus 4y squared. That example is about as tough as it will get. Now I'm going to show you one more thing that could happen. We have two parentheses. They almost look like they're the same binomial, except you'll notice one is positive and one is negative. So when I multiply those, I get x squared, and then x times negative 5 is negative 5x, in the middle positive 5x, and 5 times negative 5 is negative 25. Now you'll notice negative 5 plus 5 is 0, so those will cancel, and we won't see any terms in the middle anymore. We just have x squared minus 25. Notice the name, it's called a difference of two squares. Difference because of the subtraction. These are two perfect squares. We can take the square root of 25 and get 5 times 5. And the square root of x squared came from x times x. And so you'll notice my examples, it looks almost the same except for the negative. And the 3 and 3 will multiply to give you 9. And the y and y will multiply to give you y squared. And so that's why it's called a difference of two squares. And so the rule is basically you're going to multiply a times a and get a squared. The two middle terms are going to cancel anyway, and b times negative b will be negative b squared. This is the only time that you won't have anything in the middle. And so one more time, we get y squared. The two middle terms cancel. Negative 3 times positive 3 is negative 9. I'll show you one more time. If you do it the whole way through, you get y squared plus 3y minus 3y minus 9. 3 minus 3 is 0. So that's why you're left with y squared minus 9. For this one, 2 times 2 is 4, and x times x is x squared. The two middle terms are going to cancel. They would have been negative 2x and positive 2x. But you'll get 0, and 1 times negative 1 is negative 1. So you see how it's a difference. 4 is a perfect square, then x squared is a perfect square, and 1 is a perfect square because the square root of 1 is just 1. And so for your checkpoints, you're going to see those two patterns. Again, you can use the patterns, you can use the formulas, the shortcuts, or if you would just like to do it the whole way through and multiply, for example, this one out twice, that is perfectly fine, but if you would like to try the shortcuts, please do so. And you'll see on the next page, that's a warm-up for tomorrow, and so we're finished, and we'll go over the checkpoints tomorrow in class. Have a good day.